Hello, this is Hans again, and we are going to play with the Jetson Nano and the Mindstorms robot again. So I hope you did a good thing last time with the video, and you recompiled the kernel like I instructed to support Bluetooth communication. Then we can continue because we need it for communication with the Mindstorms. And I will show you here. This is the Bluetooth dongle that you need to add for the communication to be set up. And let's first check the Mindstorm itself. This is the Tricky model. This is the basic model. That's one of the 5 models from the Mindstorms set. Let's switch it on. By the button here. And I can show you the move that it can make. So this is, I will switch to the one of the programs. So this is a preset program, and I can start it by clicking the button again. So just move, just move around, and it has made a full half circle, and then I can try again to turn back. So this is one of the moves it can make, and so the purpose of the goal of this video is to let it be controlled by the Jetson using the Jetbot notebook that is provided. I will show that later on. First, I will tell a little bit more about the Tricky model, because we need some more details about how to make the moving instructions. First, we can see here, this is the Tricky model. If I click on this I can see here the get started. This will show how to instruct it. Right. And that's easy to build, and then you got the basic model that we will use for being controlled by the Jetson Nano. Let me show you how to see what instructions we will use. This is the code button here, and if I click it, yeah, you can see here that the 0, that was the basic instruction that I demonstrated just now. It was one of the program. So this is the one of the preset programs. And if I click on plus here, I can switch to the Python department. That's interesting for us, because the under the hood the Mindstorms has a Pi board, and that is actually used for receiving the and executing the instructions. So let's create this one. Oh yes, we are now switching to the Python department, which has this basic initial template. And this kind of code we need to send to the Mindstorms from the Jetson Nano. So this will just do a beep, but there are more instructions over, you can see in the manual here. We want to control the motors. Motor pair. Yeah, the motor pair. We will use it to control 2 motors at the same time, and they. With A and B, you can select the motor, and there are several actions. Let's see the starter tank. Yeah, so this is actually similar to what Jetbot is using. You can give 2 speeds for the left and right wheels. And the values have to be -100 to +100. And this is an example. So this short piece of code we will send to the Mindstorms. This is for the motor pair, and we also have codes for a single motor. Where is it? Single motor, yes. That's even more simple. With also the actions here, we will use start and stop. So if you use start, you can also give a speed with a value. It's as simple as that. This is the thing we will use. Okay, let's close this. Now we will have a look at the Jetbot. The Jetbot is here on this page, and it is also a similar type of robot, and there are actually multiple types of Jetbots. So let's see if we scroll down. Jet Racer, getting started. Okay, let's go to the getting started. Yes, there is a third-party link here, third-party kits page, and then you can see the other models that are already there. So the Mindstorms is not yet there, but we can adjust the software to be compatible with the Jetbot code. And then after we do that, we can run this first example, the basic motion example, to demonstrate that we can use the same type of instructions. So this will be done with a Jupyter notebook. So let's check the code for the Jetbot that is used for running instructions. We have the Jetbot GitHub here, and this is the motor code, which is a bit similar to what we saw for the Mindstorms. Let's scroll down. Yeah, you can set the speed for the motor and give a run command. As you can see, this is done for other foot motors. So we need to change this code a bit to be compatible. Let's go to the other file, and it's all Python, so that's good because we have the Python examples already. The robot file, this is the main file that needs to be changed with the left motor and the right motor. And these are the commands that we saw. These have to be similar to the ones that we are going to implement for the Mindstorms. So we are now going to have a look at the Jupyter notebook that is provided by the Jetbot software. You can see here that I connected to the Jetson Nano with this IP address, and we see the folder structure from the Jetson Nano with the Jetbot over here. Then I zoom in, then we see the actual GitHub directory that I demonstrated just before, with also the robot code and the motor code here. So you can see that I changed the robot code, and I used the MicroPython code to use the PyBoard class that is used for controlling the PyBoard. And when I scroll down, then I arrive at the motor class. This has been adjusted to run the motor commands that we saw earlier for the Mindstorms. They are over here. So I was a bit careful with the values, that if they are greater than 0.1, then I run the command with the start method. But if the value is too small, then I will just stop the motor. And below this is the robot class, which is also set up for the Mindstorms. This is the serial communication device property that is used for connecting the Jetson Nano with the Mindstorms. And these are the left and right motors that we saw in the original code for the robot, but this one is using the Mindstorms command. So first, when it was initialized, it will give a message on the Pi board, and here are the methods that I used for the controlling the motor. You can see this is a little bit confusing, EF and AB, but it will use the A and B motors. And this is the stop command. So now we are ready to run the instructions that are provided by the Jupyter notebook. Let's run the basic motion demo on the Jupyter notebook. And we can do that by selecting all the instructions one by one. First we import the robot. Then we initialize it, and we will see a message on the display if we do that. Yes. All right, then we can move to the next commands to turn it to the left and stop it. Then we import a time package and we can run it with a timer. Oops. Let's stop it because we didn't do it correctly. We import time. Okay, now we can run it. Yes, correct. Let's continue with the next instruction to control the motors individually with the set motors method. Oops, crashing into the Jetson Nano. And run this command. And now we're going to add some sliders that we can use to control the motors. First we have to link it, and then we can use the slider. Let's check it. Okay, right wheel and working. So I will skip this next instruction here with the bidirectional link. I will move to the button section here. Add the buttons, and also need to define the actions. Okay. And the click events. Then I can use the buttons. Oh, backward, left, and right. All working. Final test is the heartbeat kill switch. Then we test at what point with the small period will it stop to run. Let's execute this line here, and then we can slide to the left to decrease the period until it's too small, and then it will stop. Exactly. yes, that's it for the example. And we can be confident that we can run the robot in the next examples. I hope you like this video, and maybe you can also try out to control the Mindstorms with the Jetson Nano, and so we can use it for upcoming experiments. And so see you next time, and thank you for watching. Bye bye.